Invisibility used to belong only in movies and fairy tales, a wizard's cloak, a hobbit's ring, a soldier vanishing into thin air. But that fantasy is quietly becoming real. Across Canada, China, Spain, the UK, and Germany, scientists and engineers are building working technologies that bend light, scatter reflections, and blend objects into their surroundings. From power-free fabrics to plasma cloaks, here's how invisibility is stepping out of fiction and into reality. Quantum invisibility material. Let's start in Canada with a company called Hyperstealth Biotechnology. For years, this company has worked in near total secrecy on something it calls quantum invisibility material. Unlike the invisibility gadgets of old sci-fi movies, this isn't a projector and it isn't a screen. It's a thin, flexible, plastic-like fabric, something closer to a sheet of cling film than a piece of futuristic armor. Embedded inside this material is an array of microscopic lenses, arranged with mathematical precision. When light hits the fabric, these lenses grab the rays and bend them, scattering them in a way that essentially erases the visual outline of whatever is standing behind it. A person, a tank, a piece of equipment, all disappear from view, not because they're hidden, but because the light that would normally bounce off them and reveal their shape gets redirected before it ever reaches your eyes. Here's the detail that makes this genuinely remarkable. It needs no batteries, no electricity, no power source of any kind. It's completely passive. Every earlier attempt at real-world invisibility technology has run into the same wall. Active systems that require constant power, bulky electronics, and heat signatures that give away the very object they're trying to hide. Hyperstealth's material sidesteps all of that. It just sits there, quietly bending light, doing its job with zero energy input. That's not a small engineering detail. It's the difference between a lab curiosity and something you could actually issue to soldiers in the field. It's no surprise that militaries from multiple countries, including the United States, India, the UAE, and Canada itself, have reportedly shown serious interest in this fabric for camouflage uniforms and equipment covers. Molybdenum trioxide metamaterial. Chinese researchers are reportedly exploring a new path toward invisibility by using a material called molybdenum trioxide as an alternative to traditional metamaterials. According to the summary, earlier metamaterials could only bend limited wavelengths of light, making them effective under certain conditions, but not across the full spectrum. The new material is said to overcome those limitations by steering visible ultraviolet and infrared light at nearly the same time, bringing researchers closer to near-perfect invisibility. One of the most exciting possibilities is its potential military application. If this technology can be produced as flexible rolled sheets, it could eventually be integrated into advanced camouflage systems for soldiers, military vehicles, armored equipment, and even temporary battlefield shelters. Such a material could significantly reduce detection by optical, infrared, and other surveillance systems, giving troops a major tactical advantage during military operations. Although the technology is still in the research stage, the summary suggests it represents a major breakthrough in optical camouflage and highlights China's growing role in the global race to develop next-generation invisibility technologies for both military and civilian applications. Plasma cloaking. Moving across the globe to Spain, a research team at the University of Extremadura has taken yet another approach: plasma cloaking. This one is genuinely mind-bending. Instead of building a cloak that sits on the outside of an object like a shell, the Spanish team has found a way to embed high dielectric and magnetic filler materials directly into a plasma layer that surrounds the object. The result is that both the object and the material covering it become invisible to electromagnetic waves. Not just the object hidden inside a separate cloak, but the entire system working together as one seamless, undetectable unit. This might sound like a subtle distinction, but it solves a problem that has haunted cloaking research from the very beginning. In earlier designs, the cloak and the object underneath it were essentially separate entities. The Spanish team's plasma-based method changes that. because the invisibility effect is built into the very shell surrounding the object, and crucially, this design shows real potential to scale up from small laboratory samples to significantly larger applications, vehicles, structures, and beyond. Portable invisibility shield. Now, not every invisibility breakthrough making headlines is happening deep inside physics labs. Some of it is showing up in far more accessible consumer-facing products. Take the London-based company Comp Invisibility Shield. Their latest device, sometimes referred to as the 2.0 model, is a portable, handheld invisibility shield made from transparent polycarbonate fitted with a series of thin optical lenses. When you look through it, the lenses scatter background light in a way that makes whatever or whoever is behind the shield appear to blend into the surroundings, creating a genuine invisibility effect in real time. It's not science fiction level perfect. The device still has real practical limitations. Most notably, it obstructs the user's forward vision, forcing them to peek around the edges of the shield to actually see where they're going. It's also currently more of a niche tool than a mass market gadget. But for specific use cases, it's already proving genuinely useful. Wildlife photographers and researchers can use it to observe animals without alerting them to a human presence nearby. Hunters can use it for concealment, and certain military and security applications are exploring it as well. It's a great example of how invisibility technology doesn't need to be flawless to be valuable. It just needs to work well enough for the job at hand. Reflective camouflage. And speaking of low-tech but highly effective solutions, let's talk about something almost embarrassingly simple by comparison: the mirror hide. This is a lightweight reflective panel, essentially a portable mirror, that hunters set up in natural terrain. Instead of trying to bend light with lenses or nanomaterials, it just reflects the surrounding environment back at anything looking toward it. A deer, a bird, or any animal glancing in that direction sees rocks, trees, or open sky reflected back, not a hunter crouched and waiting. It sounds almost too basic to work, but that's exactly the point. For animals that rely heavily on visual cues to detect danger, a well-placed reflective surface can be just as effective as a multi-million-dollar cloaking material at a fraction of the cost and complexity. It's a reminder that not every solution to an old problem needs cutting-edge physics. Sometimes, the simplest idea, executed well, gets the job done just as effectively as the most advanced material science. Mercedes-Benz's LED screen car. Finally, let's look at one of the most visually striking demonstrations of invisibility technology in recent memory: Mercedes-Benz's disappearing car. This isn't invisibility in the classical physics textbook sense. There's no light-bending metamaterial, no plasma cloak, no quantum fabric involved. Instead, Mercedes covered an entire vehicle with LED screens and mounted cameras on the opposite side of the car from each screen. Those cameras capture a real-time feed of whatever is directly behind the vehicle, and that footage gets displayed instantly on the screens on the front-facing side. The result, especially when the car is filmed in motion, is a genuinely convincing illusion. The vehicle appears to visually dissolve into its background, as if it simply isn't there. Technically speaking, this is dynamic visual camouflage rather than true optical invisibility. The car isn't manipulating light at a physical or quantum level. It's essentially become a giant wraparound video screen displaying a live feed of its surroundings. But the effect is striking nonetheless, and it shows something important. Invisibility doesn't have to come from exotic new materials alone. The bigger picture. Taken together, these 6 very different approaches: passive lens-based fabric, exotic nanomaterials, plasma-embedded cloaking, portable optical shields, simple reflective panels, and dynamic camera and screen camouflage, paint a picture of a field that's exploding in creativity and momentum. What's especially notable is how differently each team has approached the same fundamental goal. There's no single correct way to build invisibility technology. Some rely on cutting-edge material science happening at the atomic scale. Others use nothing more advanced than a well-angled mirror. Some need serious funding and years of research to develop. Others could be assembled from parts you'd find at a hardware store. The demand driving all of this innovation comes from multiple directions at once. Militaries around the world, including those of major global powers, are pouring resources into invisibility research, seeing clear strategic value in soldiers, vehicles, and equipment that can evade detection on the battlefield. At the same time, civilian applications are expanding just as fast. Wildlife researchers want to observe animals without disturbing their natural behavior. Photographers want to capture moments no camera could get if the subject knew it was being watched. Even entertainment and automotive industries are exploring these technologies for entirely different purposes, from stunning visual demonstrations to future design concepts. What's clear is that we're no longer talking about invisibility as a distant, theoretical possibility confined to physics journals and speculative fiction. It's becoming a genuine, functioning field of engineering, one where different disciplines, from optics and material science to electronics and even simple mechanical design, are converging on the same extraordinary goal from wildly different directions. Passive quantum fabrics that need no power, nanomaterials that bend light across multiple spectrums at once, plasma layers that hide entire systems seamlessly, portable shields you can carry in a backpack, a mirror you can prop up in the woods, a car covered in screens. None of these technologies alone gives us the perfect all-purpose invisibility cloak of science fiction. At least not yet, but each one solves a piece of the puzzle, and each new breakthrough builds on the lessons of the last. If this pace of innovation continues, the line between magic and material science is only going to get blurrier. What once required a wizard's spell may soon just require the right material, and increasingly that future doesn't feel far away at all.